Okay, the next thing we're going to look at is how we solve a rational equation. We're going to go through certain steps, as you can see on your handout here. We will first look at any of our domain restrictions that would make our denominator equal to 0 or undefined. We will then find the least common denominator of every single term that we have in the equation, and then we will go back and we will multiply every single term by that least common denominator. And finally, we will go back and solve and check. So let's take a look at our first one. We have 4 over x plus 3 equals to 7 over x minus 4. So if we look at the denominators, we see an x plus 3, we know that that would go to 0 when x equals negative 3. And x minus 4, we know that that would go to 0 when x is positive 4. Then the next thing we're going to look at is the least common denominator. We will need to have the x plus 3. We will also need the x minus 4. Now we're going to go back and multiply both. We have two expressions here, one on the left, one on the right. We'll go back and multiply those with that common denominator, the x plus 3 and the x minus 4 on both sides. And as you see, what's actually going to happen here is this x plus 3 on this side will cancel. That would leave us with 4 times the x minus 4. And we would distribute that, so that would give us 4x minus 16 equals, and then on our right-hand side, it is our x minus 4's that will cancel, and then we're left with 7 times the x plus 3, which would be 7x plus 21. And then we would just continue to solve this as a regular equation. We would move our 4x over, so that would give us 3x here. We would move the 21 to the other side as a negative 21, so that would leave us with a negative 37, giving us a final answer of x equaling negative 37 divided by 3. So recapping, we looked at our restrictions over here. We find, in fact, that the negative 3 and 4 are not our solutions, and using our least common denominators, we were able to cancel out the existing denominators, which is what you want to do, and we end up with that negative 37 over 3. All right, I'm going to move down to our second one here. Okay, our next one, we have 1 over x plus 13 over 3 equals 7 over x. So first of all, we're going to look at the restrictions. Our denominators, we have x and 3. We know that that x cannot be 0, so that's our restriction. Our least common denominator, we have an x and a 3, so that would give us a common denominator of 3x. So we're going to go back and multiply through all of these expressions with that common denominator. So the 1 over x times the 3x, you may want to put these over 1 so you know what you're doing, plus our next one, 13 over 3 times that 3x, again, if you want to put that over 1, equals the 7 over x times, again, the common denominator of 3x. And you may put it over 1 if you like. Let's go back and cancel out. All right, here I have 3x times 1 over x, so I know that my x's will cancel, leaving me with a 3. And then plus, over my next one, my 3's will cancel. That would leave me with 13x. And then on the right-hand side, it is the x's again that will cancel. That would leave me with 7 times 3, or 21. Simply now solve this. This would be 13x equals 18, or x equals 18 divided by 13. And we can see that we have not ended up with our restriction, and we could go back and check that. All right. I'm going to come on the back side here. We're going to take a look at number 4. This is a little bit different. This one we actually end up with a quadratic. So first of all, we'll look at our restrictions. Our restrictions here are since we have an x plus 2 in the denominator, therefore x cannot be a negative 2. Our least common denominator will just be the x plus 2. Now let's go back and multiply. We have 3 terms, and we will multiply all of them by the x plus 2. So x over the x plus 2 times the x plus 2. Again, you may want to put that over 1. Plus the x. You may want to put the x over 1 as well. Keep everything straight. Times the x plus 2 again over 1 equals the 5x plus 8 over x plus 2 again times our common denominator of x plus 2. Now let's go back and cancel out. X plus 2's will cancel here. All we'll have left is an x plus, no canceling here, so distribute your x. And that would give you an x squared plus 2x equals the 5x plus 8. The x plus 2's cancel. And that's all you have on that side is 5x plus 8. As we see here, we do have a quadratic. We have an x squared. I'm going to combine my like terms and kind of clean this up. I'm going to have x squared plus 3x equals 5x plus 8. We have a quadratic. We know that quadratics, in order to solve them for their zeros, we have to make this equal to 0. So we will move the 5x and the 8 over as their opposites. That would give us x squared minus 2x plus 8 equals 0. Use your x method to factor that. You have your 8. Well, okay, here we go. And our negative 2, so that would give us the negative 4, positive 2. So x minus 4 times the x plus 2 equals 0. Therefore, x minus 4, x would be positive 4, and x plus 2, that would go to 0 when x is negative 2. Now, let's go back up here to our restrictions. We see that x cannot be that negative 2, so that negative 2 will get thrown out. Remember, we call those extraneous solutions, therefore giving us an answer of 4. All right. Well, you have 2 on here. You have number 3 and number 5. I would like for you to go back and work those on your own.